Okay, we've got a block here off the bath. It's a hot, cold and diverter. We've got bath and we've got a shower. We've also got body jets, but they're blocked off of those. So the spray on here will be the body jets. Shower head, plunge will be bath. Right, let's start off with the hot tap. I've pre-disassembled this and let's just pull it apart. So this is pre-restoration, is this. I think we're going to have to replace these shafts because we've got quite a bit of these shafts here. We've got a bit of wear in the threads which is causing a hammer effect. You can see the play, you can probably hear it as well. It's going to need new jumpers in here as well. The other thing I'm going to do is, this has been built up with PTFE to seal, so I've got some new O-rings. I'm going to machine this out here, this base or the flange part here, to accept the O-ring, so it'll seal against this surface pretty well. Now the gland nuts, I might bore them out so we've got a better fit on the shaft here when I make some new shafts. The shafts are quite worn as well on here. If I can get it out. You don't know if you can see on the video, but the groove in here is really bad. So we'll have new shafts. We'll have to put some square flats on here, and we've obviously got wear within the threads here and here, so we're going to have to make some new shafts up, new jumpers. And if we put some PTFE gland packing material in here, we'll get especially with a new shaft, we're going to get a good seal. I think I'll pop this on the milling machine as well and put some new flats on there, because they're quite gnarled of those, so it's difficult to actually tighten the thing up properly. The diverter handle, this would have had some it had some wood on here originally, so we'll turn some oak for that, and I'll just strip this down. The nut, the gland nut here, again the shaft is really badly worn, so I'll probably remachine that, and we'll clean this up and maybe remachine the centre of the gland nut out. The flats here for the spanners, that's really badly gnarled, is that. So what I'm going to do is I'm going to put this plate in the lathe, machine that down to a cylinder, and then I'll cut a piece of bar, machine that down as a sleeve to go over here. I'll silver solder it in place, then I'll pop it in the milling machine and cut some new flats, so you'll have a bit of meat there. Same again, I've got another O-ring here, so instead of having all this PTFE built up, I'll machine this flange area out to accept an O-ring, so I'll get a better seal, because the mating surface looks okay. Now the actual valve part, if you like, or the flanged disc, the centre pin has worn away, so I'm going to have to put a new pin in there. That's missing, that's just worn away. We've also got a nail holding this together, so that all needs to come apart and be sorted out. The shaft again needs really machining down. I may have to make a completely new shaft for this, because it's worn away quite heavily here, and it's going to be smaller than the diameter of the square here, corner to corner, so that's a potential problem, is that. So we might have to make a whole new shaft for that, so that'll get sorted out. The surfaces in here are pretty much okay. There is some scoring, but it's not the end of the world. On the underneath, these threads here, they're all the same. They're a non-standard thread. They're actually 1.5" OD. They're 11 TPI, and they're not. They're a BSP, so thread form, but they don't correspond to either inch or 1.25" BSP. They're somewhere in between. So the fittings here, you can see they're quite a state. It must be very difficult to actually get them to seal. They look like a steel nut. It could be a brass one, I'm not quite sure. It's been brazed onto a copper reducer. So I think what we'll do is we'll machine some brass in the lathe. I'll screw cut it in the lathe. So we've got an adapter that'll go on, a thread that'll go onto here, and I'll silver solder that onto some sort of commonplace fitting so that the pipework can be connected up very easily. And I'll probably clean these faces up here so that we can put maybe fibrous washer or something in there so it's easy to connect up. And the underneath here, I'll clean all this lot off. There's an awful lot of, not really sure what it is, it's maybe some sort of putty or something that's set now. And we'll put a nitrile cork gasket. I'll cut one to go underneath here. So plenty to do, and we'll get the video camera out once we've gone a little bit further. Obviously things like the gland nuts, there's been various spanners, pipe spanners, all sorts of bits and pieces have probably been on here, so it's made quite a mess, so I'll put them in the lathe and I'll clean them up as well, just to tidy them up. So I think that's it for the moment. See you in a bit. I'm just going to add to the previous session, and again it's probably a little bit difficult to see in here, but the seat for the rubber on the jumper it's almost rebaited in, and one problem we've got is obviously this hammering effect with the valves. And I think one of the problems we've got is because the washer and the jumper slide down almost in like a bore. It's almost like a piston sat in a cylinder. As someone's trying to regulate the shower to get the temperature right, as the valve is slightly open, it's causing a hammering effect. Now we do need to be putting really a one-way check valve as close as possible under here to try and stop that from happening. But I'm also, once I've cleaned all the rubbish off underneath, I'm going to see if I can just splay out that rebate just to allow the water to come out the feed a little bit easier, because as I say, I think as it's been regulated it's so close to the seat that we've got this problem of some sort of turbulence and pulsing effect forming within this chamber. I think if it had been just a flat seat with no rebate, it would have probably been okay. And the hammering effect is exaggerated because the threads on the shaft are worn. So this valve body, I'm going to have to machine this out and cut a new thread for a thread in here and a mating thread obviously on the new shaft, which will be great fun. Okay, right, that's it for now. Okay, I've got a bit of machining done now. The fittings I've made for here, this is we're at a sort of halfway stage. I've cut an internal thread on here to match these threads, because these threads actually are a non-standard thread. So this will go onto here, and I've just machined these discs out, which I've got to silver solder into here. See, I've put a rebate in here, so that'll drop into there. Once I've silver soldered that in, I can machine that, put a hole in, and a rebate. You can see I've machined these here, look. So there's a little rebate in there. That'll be silver soldered into here. This is for a 22mm pipe, so there'll be a nut and an olive to go in there, which will go on here. So it's easy connection. Then we can put some check valves in there. The central one, this is for the body jets, and that's blanked off, is that. So again, I've made the same fitting there, which I'll solder this disc in, and that'll just be left blank. And I've got to just file the tops of these down, and I've ordered some fibre washers. I'm going to put some fibre washers in here, so these will tighten down onto a fibre wash and do a really good job. Now, one problem I've come across is the centre plate for the diverter. Because this thickness here is so thin, over time the spanners have distorted this internal diameter here. There's also a whacking great big crack down here, and I've also noticed that this thread on this nut, it must have been cut. Maybe it's used for something else, but it's actually a taper thread, So the more you screw it down, the tighter it gets, but obviously in this case, because this is distorted, there's a real problem here. And also, if you look here, look, you can actually push the thread in and out of the internal thread there. So the whole lot there is absolutely jiggered. So what I'm going to do is I'm going to make a whole new nut for this. I'll cut a thread and I'm going to cut this off here completely. I've just found this bit of brass bar here which I used for a jig. I'm going to machine this, silver the two together, and then in the lathe I shall bore this out and I shall cut a thread in here on the lathe. Same with this as well. It's got to be done in the lathe, gripped like this, so that it's central and is actually square as well, because obviously the disc needs to sit nice and square on its mating face, the seat within the block. Right, update later. Cheerio for now. Okay, another update. Right, these were the tap valve blocks. You can see I'd machined this down. I've now made these collars out of this solid bar. So what I'm going to do next, I'm going to silver solder that onto here. Now once I've done that, I'm going to grip it in the lathe here and just remachine that down to true it. Once I've done it, I can then turn this around and use that as a fixture, so then I can get in here and sort that thread out. Once I've done that, this can obviously go in the milling machine and it can have the flats put on for the spanner. Okay, that's that bit. The plate for the diverter has now been machined down, and again I've machined this down. This will be silver soldered in here, and then I can machine this. What I will do, I'll grip it in the lathe so I can cut this thread, machine the outside down. Flats are going to be put in on the milling machine. Now the nut, the gland nut for the plate, what I've done is I'm recycling that. I've cut the thread off, and you can see I've remachined it down. It's come up quite nicely. I've got to reform those flats. What I've done here is I've out some solid bar, I've cut this blank, and I've also cut this thread, which is the same as that one. And what I'm going to do is I'm going to silver solder that into there, and then once I've cut the thread in here, I'll screw that into there, and then while it's all in the lathe, I'll then bore this out for the shaft of the diverter, and that way it'll be true to the entire workings of the diverter. Anyway, that'll be a lot better. We'll get a nice fit there. The diverter plate itself, I've bored, the pin was worn, and also the locator for the original. This is going to be replaced here, so that will go into here. I'm going to silver solder that in. I'm also going to cut a new pin here to line up with the seat in the body. This will be machined down to fit the new shaft for the diverter. So there we go. Right, back again in a bit. Okay, back with another update. You can see I've set up here the one-way check valves and the various fittings that have been made. We've got a blanking plate for that central one here. These have obviously been filled in now and machined out to take those fittings there, so that's got to be soldered together next, and then they're done, and then obviously there's a fibrous washer to go in there, and that's that. The bodies for the tap valves, they've been soldered together now, so that can be gripped in the lathe, that can be trued. I can spin it round to grip it, and then we can fill this in with a new and put a new thread in there. The diverter disc has now got a new shaft in here. That's going to have to go in the lathe and be turned, so the pin needs to be turned down here, and then the shaft itself will be turned down. And let's see the tap body. This is some solid brass rod. I'm going to turn these tap shafts out of that. So we've got a thread to cut, we've got a hole to put in here, we've got some flats to put on here for the tap head, and then we've got a thread to put in here for the captive nut. I've started machining this bar down. There we go. I've turned this section down here. This is your diverter shaft. So this is the boss at the bottom that will obviously go onto there, like that. So again, this is going to be machined down, and then I've got some flats to put, and we've got a thread to put in here for the handle. The jumpers are started. Just bring all the bits over here. Okay, so this is the one of the original jumpers. I don't know if you can see from the video, but it's heavily domed. It's jiggered, and I'm making some new ones. You can see these are a much beefier jumper. They're a slightly bigger diameter as well. One thing I did find with the washers that were in the block for the taps, the washers themselves were too big. They should have been a bit smaller really, because obviously what's happening is you're filling that bore out and it's creating almost like a piston in a cylinder effect. So I've cut some new rubber washers here. This is the shaft which is going to go into here. This is going to be silver soldered together, and then I shall have to, this is a tight fit, I'm going to cut a thread on here, an M8 thread. This will go over, and then I've turned these out some solid bar. These will be a washer that's going to have a hole in the middle, then you'll have a nut, so that'll be quite a solid serious jumper when it's done. I'm just cutting the thread for the diverter plate, so I'm going to move over to the lathe in a minute and show you a bit of live action thread cutting. Okay, see you in a second. Okay, here we are over at the lathe. Now this is a very old lathe. It came over during the Second World War in an American service truck. So it's a South Bend lathe, about 1942. They're still in existence, the company. I've actually spoken to them in America. And so what we're having here is the diverter plate. You can see here, here's the new bush that I've machined and silver soldered on. I'm now cutting a thread in here. I'm just going to show you the nut. So here's the nut. That's now been, if you remember, we've recycled this head of the nut, and I've silver soldered in that. So that's going to be machined. It's got to have a hole in it for the shaft, but that'll be done once this can be screwed into here. But I'm cutting the thread at the moment. So this is a back geared lathe. So this shaft here turns, goes through here, okay, and then it powers all this set of cogs on the back here, which then goes through a gearbox, which I can use to set the pitch. That's the tips per inch, the teeth per inch, if you like, TPI of the thread, various levers and one thing and another. So it's powered through the shaft here, which then moves this saddle in and out. And I've also got a dial indicator here, because I've got to index the cutter at the right time to pick up on the thread. So I've got it all set up, so I'm just going to run one through so you can see it working. Right, so that's powering away now. You can hear it cutting. Okay, that's one pass. I'm going to do multiple passes. I can't put too much stress on this because I'm very lightly gripping this plate. I don't want to exert too much pressure on this plate because it'll actually distort this thread here. Okay, right, I think I'll put this on YouTube, and this will be part 1, and I'll do part 2 for the second half. Okay, I just thought I'd add to the video, so this is quite an interesting point, is this. These are the tap shafts, which I'm obviously going to replace, and here is the very start of the process. You see it's quite a lump of brass here, and you can see the thread I've cut on the end here, which is rather smart. So there's a long way to go yet. I've got to turn this portion down next, and I've also got some flats to put on here, and there's the thread in the end. I'm going to bore that end out as well for the jumper. Right, okay, cheerio.